Installing an electrical breaker that doesn't sit flush within your electrical panel can introduce several concerns. Firstly, misalignment is a significant risk. If the breaker isn't perfectly aligned, it could lead to loose connections. These loose connections can then cause overheating, potentially resulting in electrical hazards such as fires or equipment failure. Secondly, latching issues may arise. A protruding breaker can interfere with the panel cover, preventing it from latching properly. This is a safety concern because a properly latched panel cover is designed to protect individuals from accidental contact with live electrical components inside. If the cover cannot latch, it compromises the entire system's safety. Thirdly, moisture intrusion is another potential issue. If the breaker isn't sitting flush, it creates a gap that allows moisture or dust to enter the electrical panel. These contaminants can damage the electrical components within, leading to corrosion, malfunctions, and ultimately, system failure. Given these concerns, several actions are recommended. 1. Contact a qualified electrician. It is strongly advised to seek professional help from a licensed and experienced electrician. It can accurately assess the situation, determine if the Siemens 50 amp ground fault circuit interrupter breaker is indeed compatible with your square D homeline panel, and address any underlying concerns. An electrician has the expertise to identify and correct any potential hazards, ensuring a safe and proper installation. 2. Check the breaker specifications. Carefully review the specifications of both the Siemens breaker and your square D homeline panel. Verify whether the Siemens 50 amp ground fault circuit interrupter breaker is specifically designed and approved for use in square D homeline panels. Electrical breakers and panels are designed with specific dimensions and configurations. Using an incompatible breaker can create a mismatch that leads to the problems mentioned earlier. Remember, homeline breakers are known to have slightly different dimensions which may not be compatible with Siemens breakers, even if they appear similar. 3. Consider returning the breaker. If, after checking the specifications, you determine that the Siemens breaker is not compatible with your square D homeline panel, return it to the place of purchase. Exchange it for a square D homeline breaker that is specifically designed for your panel. Using the correct breaker type is essential for safe and reliable operation. As a temporary solution, understand that this is not recommended as a long-term fix. You might consider securing the breaker in place temporarily to prevent it from moving within the panel. This could involve using electrical tape or zip ties, but this is strictly a temporary measure. It is crucial to understand that it addresses only the physical stability of the breaker and does not resolve any underlying compatibility or safety issues. This temporary fix should only be considered until a qualified electrician can assess the situation and provide a permanent solution. Electrical panels and breakers are not universally interchangeable. They are designed to work together as a system, and using incompatible components can have serious consequences. It is best to prioritize safety and consult with a professional electrician to ensure that your electrical system is properly installed and maintained. Remember, electricity can be dangerous, and it is always better to err on the side of caution when dealing with electrical work. Never attempt electrical repairs or installations if you are not qualified to do so. Always seek the help of a licensed electrician to ensure your safety and the safety of your property. There are several reasons why a breaker might not sit flush in an electrical panel. Firstly, physical incompatibility is a major reason. Breakers from different manufacturers, like Siemens and Square D, may have slightly different physical dimensions and designs, even if they appear similar at first glance. These differences can prevent the breaker from properly seating in the panel. Secondly, incorrect installation can cause problems. If the breaker is not properly aligned or fully engaged with the bus bar, it will not sit flush. This can happen if the breaker is forced into place or if the mounting clips are damaged. Thirdly, damage to the panel or breaker can create issues. A damaged bus bar, mounting rail, or breaker housing can prevent proper seating. Even a small amount of damage can cause misalignment and prevent the breaker from sitting flush. Fourthly, foreign objects or debris inside the panel can obstruct the breaker. Dirt, dust, or small objects can get lodged between the breaker and the panel, preventing it from sitting flush. Therefore, troubleshooting this issue involves several steps. Begin by visually inspecting the breaker and panel. Look for any signs of damage, such as cracks, bends, or broken pieces. Also, check for any foreign objects or debris that might be obstructing the breaker. Ensure the breaker is the correct type for the panel. Verify that the breaker is designed to fit the specific type of panel you have. Check the manufacturer's specifications to confirm compatibility. Turn off the power to the panel before attempting any work. Safety is paramount when working with electricity. Use a voltage tester to ensure that the power is off before you proceed. Carefully try to install the breaker. Align the breaker with the busbar and mounting rail. Apply gentle pressure to snap the breaker into place. Avoid forcing the breaker, as this can cause damage. If the breaker still does not sit flush, remove it and inspect the panel and breaker more closely. Look for any signs of damage or misalignment. If you are unable to resolve the issue yourself, contact a qualified electrician. An electrician has the tools and expertise to diagnose and repair any electrical problems safely and effectively. Remember, working with electricity can be dangerous. If you are not comfortable working with electricity, do not attempt to repair the problem yourself. Contact a qualified electrician instead. Always prioritize safety when working with electricity. The National Electrical Code, NEC, provides guidelines for safe electrical installations. Some relevant sections include NEC 110.3b, which covers the suitability of equipment. This section requires that electrical equipment be suitable for the intended use and installed according to the manufacturer's instructions. Using a breaker that is not compatible with the panel violates this requirement. NEC 408.36 covers overcurrent protection. This section requires that each circuit breaker be protected by an overcurrent device. Using an incompatible breaker can compromise the overcurrent protection, creating a safety hazard. NEC 110.12 covers mechanical execution of work. This section requires that electrical work be performed in a neat and workmanlike manner. Installing a breaker that does not sit flush violates this requirement. NEC 312.2 covers the installation of conductors in enclosures. This section requires that conductors be properly installed and supported within enclosures. Using an incompatible breaker can make it difficult to properly install and support the conductors. Always consult the latest edition of the NEC for the most up-to-date requirements. The proper installation of electrical breakers is essential for the safe and reliable operation of electrical systems. Following these guidelines can help ensure that electrical installations are performed safely and correctly. Remember, electricity can be dangerous. If you are not comfortable working with electricity, contact a qualified electrician. The long-term consequences of using an incompatible breaker can be severe. Firstly, there's an increased risk of electrical fires. Loose connections and overheating can ignite nearby materials, leading to a fire. Secondly, equipment damage can occur. Overheating and voltage fluctuations can damage connected appliances and equipment. Thirdly, electrical shock hazards are a concern. A misaligned breaker can create exposed live parts, increasing the risk of electrical shock. Fourthly, the entire electrical system's reliability is compromised. An incompatible breaker can cause frequent tripping, power outages, and other electrical problems. Finally, there are potential code violations. Using an incompatible breaker can violate electrical codes, leading to fines and penalties. To avoid these consequences, take the following steps. Always use breakers that are specifically designed for the panel. Check the manufacturer's specifications to confirm compatibility. Ensure that the breaker is properly installed and seated in the panel. Do not force the breaker into place. If you are unsure about the compatibility or installation of a breaker, contact a qualified electrician. They can help you choose the right breaker and install it safely and correctly. Regular maintenance and inspection of your electrical system are also important. Check the breakers regularly for signs of damage or overheating. If you notice any problems, contact an electrician immediately. Proactive maintenance can help prevent electrical problems and ensure the safety of your home. There are different types of breakers available, each designed for specific applications. Standard breakers are used for general-purpose circuits. Ground fault circuit interrupters, or GFCIs, protect against ground faults, which can cause electrical shock. Arc fault circuit interrupters, or RFCIs, protect against arc faults, which can cause electrical fires. Dual-function breakers combine ground fault and arc fault protection. Choosing the right type of breaker is essential for safety and code compliance. When selecting a breaker, consider the following factors: the amperage rating of the circuit, the type of load being served, and the code requirements. The amperage rating of the breaker should match the amperage rating of the circuit. The breaker should be designed to handle the type of load being served, such as lighting, appliances, or motors. The breaker should comply with all applicable electrical codes. When replacing a breaker, always use a breaker of the same type and amperage rating. Never use a breaker with a higher amperage rating, as this can overload the circuit and create a fire hazard. The physical dimensions of circuit breakers are also important. Circuit breakers come in different sizes and shapes, and it is important to use a breaker that is compatible with the panel. The breaker must be able to physically fit into the panel and make proper electrical connections. The circuit breaker's trip curve is another important factor. The trip curve describes how quickly the breaker will trip under different overload conditions. Different types of loads, such as motors and transformers, may require different trip curves. Selecting the appropriate trip curve can help prevent nuisance tripping and ensure proper protection of the circuit. Additionally, the interrupting rating of the circuit breaker is crucial. The interrupting rating is the maximum amount of fault current that the breaker can safely interrupt. The interrupting rating of the breaker must be greater than the available fault current at the point of installation. Using a breaker with an insufficient interrupting rating can result in a catastrophic failure of the breaker during a fault condition. Furthermore, the ambient temperature can affect the performance of circuit breakers. Circuit breakers are designed to operate within a specific temperature range. High ambient temperatures can cause the breaker to overheat and trip prematurely, while low ambient temperatures can cause the breaker to become less sensitive. It is important to select a breaker that is suitable for the ambient temperature conditions at the point of installation. Lastly, the altitude can also affect the performance of circuit breakers. At high altitudes, the air is less dense, which can reduce the breaker's ability to dissipate heat. This can lead to overheating and premature tripping. It is important to select a breaker that is rated for high altitude applications. When choosing a circuit breaker, consider all of these factors to ensure safe and reliable operation of the electrical system. Always consult with a qualified electrician if you have any questions. The electrical panels are designed with specific busbar configurations. The busbar is the metal strip inside the panel that provides the electrical connection points for the circuit breakers. Different panel manufacturers use different busbar designs, and it is important to use breakers that are compatible with the busbar. Using an incompatible breaker can damage the busbar and create a dangerous electrical hazard. The panel's labeling is also important. Electrical panels are required to be labeled with information about the panel's voltage, amperage, and interrupting rating. The labeling also provides information about the types of breakers that are approved for use in the panel. Always refer to the panel's labeling before installing or replacing a breaker. Proper grounding of the electrical panel is essential for safety. The grounding system provides a path for fault current to flow back to the source, which helps to trip the breaker and prevent electrical shock. The grounding system must be properly installed and maintained to ensure its effectiveness. Regularly inspect the grounding system for signs of corrosion or damage. If you notice any problems, contact an electrician immediately. Surge protection is another important consideration for electrical panels. Surge protectors help to protect against voltage surges, which can damage sensitive electronic equipment. Surge protectors can be installed at the main panel or at individual outlets. Consider installing surge protectors to protect your valuable electronics. Arc fault detection is a relatively new technology that is designed to prevent electrical fires. Arc fault detectors can detect dangerous arc faults, which are caused by damaged or deteriorated wiring. When an arc fault is detected, the arc fault detector will trip the breaker and shut off the power to the circuit. Consider installing arc fault detectors in your home to provide an extra layer of protection against electrical fires. Load calculations are an essential part of electrical system design. Load calculations are used to determine the amount of power that will be required for a particular circuit or building. The load calculation takes into account the size and type of electrical loads that will be connected to the circuit. The load calculation is used to determine the size of the breaker, the size of the wiring, and the size of the electrical panel. Performing accurate load calculations is essential for ensuring that the electrical system is safe and reliable. Permits and inspections are required for many electrical installations. Electrical permits are required for new electrical installations, modifications to existing electrical systems, and a replacement of electrical equipment. Electrical inspections are performed to ensure that the electrical work is performed in accordance with applicable codes and standards. Obtaining the necessary permits and inspections is essential for ensuring that the electrical work is safe and compliant. Regularly inspect your electrical panel for signs of problems. Look for loose wires, corroded connections, and damaged breakers. If you notice any problems, contact an electrician immediately. Regular inspections can help prevent electrical problems and ensure the safety of your home. Replacing an electrical panel is a complex and potentially dangerous task. Replacing an electrical panel should only be performed by a qualified electrician. An electrician has the training and experience to safely and effectively replace an electrical panel. If you need to replace your electrical panel, contact a qualified electrician. Remember to always consult with a qualified electrician for any electrical work. Working with electricity can be dangerous. If you are not comfortable working with electricity, contact a qualified electrician.